Hey, it's Steve. It is April 10th, 2017. The time is 12:05. It is 72 degrees Fahrenheit out, and I am breaking out like crazy. I'm in my 40s, and I still get acne like a teenager. But anyway, today I want to talk about perception and science news because I see a lot of misinformation in science news sources, okay? And I'm sure most of it is not intentional, but you got to remember something about science news sources too. Number one, some of them may not be science, especially just stuff random on the interwebs. But another thing is they're trying to sell you something. They want to get you interested in something, and they want you to read the article. Now, what does this have to do with perception? Well, I've seen many things, like when hydroxyl bonds in the mantle were first reported, the science news media sat there and put big pictures of like flowing water in oceans and saying there's water in the mantle. No, wrong, fail. It's OH bonds with the minerals in the mantle. It's not true water, and it sure as hell isn't free flowing in oceans. But there's one I'm going to talk about specifically because this one really irked me. It was an astronomy one. This does tie into geology, and I'll get to that here, but just let me explain this part. The article said that the Earth was the sun was 109 times larger than the Earth, or 109 times bigger than the Earth. Yeah, that's like an epic fail. The sun is 109 times the diameter of the Earth, but we live in space-wise, we live in a three-dimensional universe. Okay, that's just one dimension. A circle's not an accurate representation either. The sun is a fucking sphere, okay? It's a ball, okay? And to put that in perspective, like how dumb that would be like if someone asked me about my land in the UP, well, what size do you have? Well, how big's your land? And I said 125 feet. Huh? Well, it doesn't make any sense. But if I said a third of an acre, even though the dimensions are not all equal, it still gives you a better understanding of how big my land is, other than 125 feet. Okay? And, just the sun is huge. It's like over 98, almost 99% of all the mass of the solar system, okay? Now, what they could have done is they could have used volume. Volume is just the amount of space something takes up. It's independent of mass. Like if I have two 1-liter beakers and I fill one with water and one with sand, yeah, this one with sand is heavier, but I still have 1 liter of water and 1 liter of sand, okay? By the way, volumetrically, how many Earths will fit inside the sun? 1.3 million. Okay? That's a hell of a lot larger number than 109. Mass-wise, the Earth is denser than the sun. The sun is basically a big nuclear reactor, and it's all gas. But the Earth is, on average, about 4 times more dense than the sun. Mass-wise, it would take 330,000 Earths to equal 1 solar mass. Okay, so either of those numbers would have been better. It gives the true size of the sun. But the reason why I bring, and when I saw that was one of those moments I wanted to reach into the interwebs and just grab the writer and editor and just, because obviously they didn't check anything. And you see, that's another thing about people reporting science news. If it's within a publication that doesn't normally do science, they probably aren't scientists. They can have a degree in communications, for all you know, or psychology. You just don't know. So I only read science if I'm not reading papers or textbooks. The only science news I read are ones with hard publications that have a long history of being right, Scientific American's kind of changed over the years, but like Discovery, those type of things. Or I watch something on YouTube that's by somebody who's an expert in their field, like PBS Space Time. The guy that hosts that has a PhD in physics, and that's the stuff he works with. So obviously he knows what he's talking about. Okay, but how does this tie into geology? Sorry, excuse me. Okay, when I go out and look at rocks and do lithostratigraphy, I often take a hand lens with me or a field microscope. A hand lens is about yay diameter. Got you look. And they'll typically be 10 to 20 times magnification. Say I'm looking at a sandstone where the grain sizes are almost all the same size, okay? When I mean size, I mean like they're all 1 or 2 millimeters in diameter or 3 millimeters in diameter. Well, when we classify sandstones, we divide them into 3 parts. The quartz, the feldspars present, which are aluminum silicates, and then the lithics, which is basically everything that isn't quartz or feldspar. I put chert in a lithics, although that is technically SiO2 like quartz, but chert is a rock fragment. It really belongs in those lithics. Okay, so, sorry, I don't know why I'm coughing so much. Okay, so, but if I'm looking and say the grain sizes are all like 2 millimeters in diameter, pretty much, and pretty well rounded. And if I get my percentages by volume, because I'm looking, we actually have charts that where we can get into accuracy within 2% of how much volumetrically each one of those 3 divisions takes up. So I get my 3 percentages. Now say I was to take 100 random grains and actually weigh them to get the mass, you know, to do it by weight, and then convert that into percentages. See, the thing with these, like those sandstones is it's not, the percentages by volume are going to be close to the percentages by weight. And the reason being is because quartz has a specific gravity, I believe, at 2.7. Feldspars are between 2.5 and 3. And most lithics, like limestone, chert, just, you know, broken down volcanic rocks, those are going to be about the same range as the feldspars. So you're going to get about the same numbers. They'll be a little different, but the volume one for most purposes is good enough. The only time you'll run into a problem is if, and then remember, this is assuming the grains are all 2 millimeters in size. If they vary greatly and it's poorly sorted, the numbers are going to vary greatly. But say your lithics are almost all hematite. Well, hematite is 2 times, I believe, denser than, weighs more, you know, specific gravity wise. Specific gravity is about 2 times heavier than quartz, so that would mess it up. Or if you have a lot of fine grain mineral like a glauconitic sand, glauconite's specific gravity, I believe, is close to quartz, but here's the thing, it's usually disseminated. It's not in good crystals, it's in these little tiny silt-sized particles, so you would actually include that in the description as silt. So you would be, instead of having an arenite, you would have a wacky. So I mean, you gotta kind of just use your best judgment with that kind of thing. But when you're reporting it, you'll sit there and say that stuff. Oh, this is percentage by volume. This is percentage by weight. You know, you're not just going to sit there and say, oh yeah, this sandstone has more quartz than it does feldspars. It's vague. It doesn't mean anything. And I know when you're reporting science news, you want people to get interested who might not be. But when it comes to something like that, people know what, I mean, in America, they know what a pound is. They know what an ounce is. You know, everyone else knows what a gram is, or a milligram, or a milliliter, or a liter. They know what these things are. So when you're talking about that stuff, you might as well as just say that. or, I mean, you're not going to throw, I mean, unless a 3rd grader's reading your article, which probably isn't your target audience, you just say that. Don't use vague, anonymous words, and don't try to give something a flashy name. No, there's no such thing as dark mantle. Okay, we know the mantle. We understand it pretty well. Okay, it's not. There's nothing ominous about it. Don't slap on some stupid term to try to coin something because you look like a moron. Okay. Well, anyway, that was my rant for today, and I hope you learned something.